Am I audible? I have just started recording the lecture. So whatever I will show here will get recorded. And once the lecture gets over, I'll share the link with madam, and she'll share the link to you guys, so that even if you have network problem, no need to worry. Okay, we'll send a recorded video of this. You can see the recorded videos and again go through the video, because I'll not give much of the time to copy down the numerical. Okay, so many times you need to take the screenshot, or then you need to go through the videos. So let's move ahead now. Now you know the meanings of the symbols. So now we are ready to use set builder form. Let me give you one more example. I have a set A and I write 1, 4, 9, 16, 25, 36, 49. Okay, now this is in the roster form. Now I want to write the same thing in the set builder form. So how should I write? So every time when you write in the set builder form, after this you have to recall a variable, and you'll write A is a set of X, such that X. Now you have to find out some rule, okay, which this particular thing is satisfying. And this is what I was saying. In the set builder form, every time you need to find out the rule. So now if you see, I have written this 4 is nothing but 2 square, 3 square, this is 4 square, 5 square, 6 square, 7 square. So you have to write that rule where X is nothing but equals to n square, and my n belongs to natural numbers, and my n is less than or equal to 7. So the moment I say my n belongs to natural numbers, which means it should start from 1. So if I say x is equals to n square, so if I put n is equals to 1, I get 1 square, that is 1. If I put n is equals to 2, I will get 2 square, that is 4. If I put n is equals to 3, I will get 3 square, that is 9. Okay. If I put n is equals to 5, I will get 5 square, that is 25. So up till I have to go up till 49. So 7 square is 49. So I'll go up till 7, and therefore I have written my n should be less than or equal to 7. Okay, so this is how you will write the same thing in the set builder form. Let me see one more. I have this 1, 3, 5, 7, 9, 11, 14, 15. Now you have to write the same thing in the set builder form. So I said you have to see a pattern. So again, B is a set of X, such that X is equal to. Now you have to see that the pattern or the rule which is number, already know that this is the odd number, but we cannot write that X is an odd number. Since we are in the mathematics, we can find out some formula which these numbers are satisfying. So you have to find out that rule which all these numbers are satisfying. We know it is an odd number, but you have to find out the rule. So you can write it as when x is equals to 2n minus 1, my n belongs to natural number, and n 2 7s are 15, 2 6s are 8s are. N is less than or equals to 8. Okay, so let us substitute and see. So if I put n is equals to 1, okay, then I'll get 2 into 1 minus 1, that is 1. If I put n is equals to 2, then I'll get 2 into 2, 4, 4 minus 1, 3, which is there. If I put n is equals to 3, then I'll get 2 into 3, 6, 6 minus 1, 5, which is there. Now if I put n is equals to 8, then I get 2 into 8, that is 16, 16 minus 1, that is 15, that is 6. So this is how you have to find out a rule, okay, which all the numbers are satisfying, and then only you have to write. So these are your roster form and these are your set builder form. So now how we know how to write? Now we know how to write the set. So there are two methods. One is the roster form and one is the set builder form. Now let's move ahead and let's see types of sets. So the first type of set we call it as finite set. So what is a finite set? Where number of elements in the set is finite. Finite means countable. You can count how many numbers of elements are there in a set. So if you are able to count, then it is finite. So both the examples which you can see on the board, set A and set B, both are finite sets because the number of elements you can count. It is not uncountable. Next, second is infinite set. What is an infinite set? Where number of elements are countless. You cannot count it. Say for example, I write C is a set of x such that x belongs to natural numbers. So now I will start counting from 1, 2, 3, 4, 5, 6, and I can go up till crores and then billions and trillions and Arabs, and I can keep on counting. Okay, till I reach infinity. Therefore, these are countless numbers. You cannot count them. So this is an infinite set. This becomes an example of infinite set. And these two are examples of finite set. Then third, singleton set. So what do you mean by singleton set? Where the number of elements in the set is only one. If there is one and only one element, okay, if there is one and only one element inside the set, then it is called as a singleton set. Suppose if I say B is a set of X such that X is capital of India. So how many capitals does India have? It has only one capital, that is New Delhi. We are not having, okay, two capitals like, okay, Canada, that is summer is different, winter is different. We don't have two, okay, capitals like Australia. We are having only one capital. So if you write the element in the set, if you write the element in the set, you will be able to write only one. Okay, and that will be nothing but New Delhi. So element which consists of only one element. Okay, it consists of only one element will be called as the singleton set. Next is null or empty set. This is always shown by symbol phi. Null set is shown by Greek letter phi. Now what is the null set? It does not contain any element. A statement does not contain even zero, nothing. Nothing is there. Then it is called as empty or null set. Okay, if water inside your bottle is over, then your that empty bottle will be called as a null set with respect to that water because nothing is there with respect to water. You can say there is air inside, but if I say with respect to water, it is empty. There is no water inside. So it becomes a null set. let us see one more example of an null set. If I say E is the set of X such that X is root of equation X square plus 1 is equal to 0, where X belongs to real numbers. Okay. So it is the root. So you have to solve this quadratic equation. You will get the root, and let us see if you are getting it belongs to real numbers or no. If I try to solve x square plus 1 is equal to 0, then I'll get x square is equal to minus 1. So I will get x is equal to plus minus under root of minus 1. This you have not studied in the real numbers. If it's like this, minus of root 1, this you have studied, this belongs to real numbers. But if minus sign is there inside the real number, then it is not a real number. You have not studied this. You will study later on in the syllabus. These are called as imaginary numbers. These are not real numbers. And this under root of minus 1 will be denoted by I, and then I can write it as equal to plus minus I, small I. And here is saying that x belongs to real number. But the answer what we get is an imaginary number. You cannot write inside the set. You are getting the root. Yes, you are getting the root. But the roots are imaginary, that is, you are getting imaginary numbers. So since you are getting imaginary numbers, you cannot write. Why? Because here is saying that it belongs to real number. So then what you will call, you will say that E is an empty set. You will say that this is an empty set. It is not going to contain any element. Okay. So hope this is clear. What do I mean by empty set? Next, equivalent sets. So when do we call that two sets are equivalent? When number of elements of sets are equal. Okay, let us see an example. There is a set F having numbers 1, 2, 3, 4, and 5. There is a set G having A, B, C, D, and E. Now, what are the number of elements in set F? So, number of elements in set F is 5. What are number of elements in set G? 1, 2, 3, 4, and 5. Here also the number of elements are 5. So, number of elements in set F is equal to number of elements in set G. If the number of elements of both the sets are equal, then both the sets will be called as equivalent sets, not equal, equivalent. Okay, the number of elements, if they are same, then they call it as equivalent set. Now, let us try to understand when can we say that two sets are equal. This is about equivalent sets. Now, when can we say that two sets are equal? If the number of elements are same, at the same time elements are also same. Okay, say for example, if I say A is equals to 1, 2, 3, 4, and 5, and set B is equals to 2, 4, 5, 1, 3. If you see set A and set B, both have same number of elements. Okay, both are having 5 elements first. Next, if you see the elements are same, though the order is not same, but it doesn't matter, right? Order doesn't matter. Okay, if you write 1, 2, 3, 4, if you write 2, 4, 5, 1, 3, it doesn't matter. The numbers, the elements are same. This is also having 1, 2, 3, 4, 5, and this is also having 1, 2, 3, 4, 5 only. The order which I have not written is just not same. But again, I can rearrange it. No? So it doesn't matter in whatever order I am writing, and I will say that the set A is equals to set B. So there's a difference between equivalent set and equal set. In equivalent set, only the cardinal number will be same. But for an equal set, the cardinal number as well as the elements both are going to be same. Then we call it as a equal sets. Okay. Now let's see next. So now we know what are equal sets. Now let's move ahead after equal sets. Let's see what do we mean by subset and superset. Okay, let's see what do I mean by subset and superset. Writing there is a set A 1, 2, 3, 4, 5. There is a set B 2, 4. There is a set C having elements 1, 3, and 5. Okay. So if you see, all the elements of set B are present in set A. Similarly, all the elements of set C are also present in set A. So I will say that B is subset of A, which can be represented as B is a subset of A. Similarly, all the elements of C are there in A, and therefore I can also say C is a subset of A. So this will be called as subset, whereas A will be called as superset. Okay, C will be called as a subset, whereas A will be called as superset. Because A is containing all the elements as well as it is having some extra elements also. Therefore, A will be called as a superset, whereas B and C both will be called as the subset. Let me write one more. Now, if you see, can I say all the elements of D are present in A? Can I say? Yes. And therefore, I can say D is a subset of A. Because all the elements of D are there in A. But we know one more thing, we have just seen equal sets. Both the sets are equal because number of elements are also same. And the elements which are there is also same. Therefore, I will have to write A is a subset of A, which gives a very important property. Okay, and then you have to remember every set is a subset of itself. Okay, you have to remember that every set is a subset of itself. Okay, so you have to remember this, every set is a subset of itself. But now if we see here, neither I can say that D is a superset, neither I can say that A is a superset. And therefore we change the symbol in this case and we show it something like this. Hence, the subsets are of two types of subsets. Hence, there are two types of subsets. One is called as a proper subset and other is called as an improper subset. So for proper subset, we'll use the symbol this, and for improper subset, we'll use this symbol. Okay, and this becomes your property kind of a thing, which you have to remember that every set is a subset of itself. Okay, another example. Next, one more. Let us try to understand how many number of subsets I can create. If I have one set, how many subsets I can create? Suppose I can say is 1, 2, 3. Now, how many subsets I can create? So I can write simply 1. This is also a subset. Then I can write only 2. So are you guys able to hear me clearly? Am I audible?
Yes, sir.
Am I audible?
Yes, sir.
Okay. So I said 2 is also a subset of A. Then I can just simply write 3 and this lies over here. So I can say 3 is also a subset of A. I can write just 1 comma 2. So but obviously this also lies in set A. So this is also a subset. I can write 1 comma 3. So this 1 comma 3 also lies in A. So this is also a subset. I can write 2 comma 3. Now 2 comma 3 also lies completely in this. So this is also a subset. Now we just saw every set is a subset of itself. And therefore I can say, I can write this 1 to 3. And I can say that 1 to 3 is also a subset of A. Because every set is a subset of itself. At the same time, one more important thing, null set. Null set is inherently subset of every set. Null set, okay, is subset of any set. So whenever you write any set, inherently by default, one subset it will always have. That is a null set. And other is every set is a subset of itself. So minimum, at least, how many subsets will be there too? One is every set is a subset of itself, and second is the null set. So every time, any kind of a set, these two subsets will always be there, which is that one is a null set, other is the set itself. Okay, so minimum two will be there, and therefore I can say number of subsets is equals to 2 raised to n. So what is n? N is nothing but number of elements. Now let's count how many subjects I have just written. 1, 2, 3, 4, 5, 6, 7, and 8. And how many elements are there over here? 3. So 2 raised to 3 is also 8. So yes, number of subsets will always be 2 raised to n, where n is the number of elements. Let us see one more example. If I write set B having elements A, comma B. Now, how many subsets I can write? First is A is a subset of B. Then if I write this also lies in this. Now every set is a subset of itself, and null set is a subset. Now, how many number of elements are there over here? 2. 2 raised to 2, that will be how much? 4. So, R and 4, 1, 2, 3, and 4. So, number of subsets is given by this formula. You have to remember this. Number of subsets is always 2 raised to n. Where n are the number of elements. Now, these are subsets. But I just told you there are two types of subsets. One is called as proper subset. One is called as improper subset. So null set is but obviously proper subset because entire null set will lie over here. So if I say proper subset, so this is not a proper subset. This is equal. So you have to remove this. Similarly here, so you will get 7. Similarly here, this is also proper subset, this is also proper subset, this is also proper subset. This is not a proper subset. Because you cannot say which is superset, which is subset. When you cannot say which is a superset and which is a subset, then you call it as an improper subset. Whereas when you can identify which is a superset and which is a subset, then it is called as a proper set. So here also you have to remove one only, there also you have to remove one only. Therefore, if I say number of proper subsets, then you just have to remove one, that is the set itself. So the formula becomes 2 raised to n minus 1. You just have to remove one set. So now if you do 2 raised to 3, that is 8 minus 1, 7. So if you remove this, only 7 will remain. Similarly, 2 raised to 2, that is 4. 4 minus 1, that is 3. So if you remove here, so what remains is 1, 2, and 3. So if it is asked, you have to read it very carefully in the exam. Is he asking number of subsets or is he asking number of proper subsets? Okay, if he is asking number of proper subsets, then you have to remove 1 from 2 raised to n. So this is like a formula. So now we know what is a proper subset. We also know what is an improper subset. And we also know the formula now to calculate the number of subsets. Now let's move ahead and see next type of set. Universal set. So this is nothing but a set, okay, which consists all the sets in a given discussion. Okay, all the possible sets which are possible in the given discussion, and if there is a set which consists of all the sets, okay, which are possible in the discussion, then it will be called as a universal set. Let us see one example. If I write A is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I write set B 1, 3, 5, 7. I write set C as 2, 4, 6, 8, 10. I write set D as okay 2, 3, 5, 7. I write set E as 4, 6, 8, 9, 10. I write. So now if you see, I've written numbers 1 to 10. Then I've written these are odd numbers, these are even numbers, these are prime numbers, these are composite numbers. I can also write okay 1, 4, 9. These are perfect squares. Then I can write one more set. These are perfect cubes. So when we talk about numbers, okay, we'll say prime numbers, co-prime numbers, okay. Then you will say composite numbers, odd numbers, even numbers, perfect squares, perfect cubes, and so on. So if I'm talking about the numbers, all these things are going to come into the discussion. So whatever things are going to come into discussion, that is the prime number, co-prime number, composite number, even numbers, odd numbers, perfect squares, okay, perfect cubes, and so on. I've written all that, and all these are present in set A. If you see set B, set C, D, E, F, G, then all the elements of this set B, C, D, E, F, and G are present in set A. So, if in a given discussion, all the possible sets, if in a given discussion, all the possible sets are present in a single set, then that set will be called as the universal set. So in this case, this is my universal set, which is always denoted by U. So if it is a universal set, you are going to denote it by U. Okay, universal set will always be denoted by U. Remember that. Okay, so it is not fixed. It depends on your discussion. What is the universal set? Universal set will change from discussion to discussion. Whichever things you are discussing about or talking about, that is going to decide what is going to be the universal set. Okay, is that clear? Now, let me move to visual representation of the set, which is also called as Venn diagram. Visual representation. This is also called as Venn diagram. Because Venn was the person, it is the name of the person Venn, okay, who invented this technique, and hence the name is dedicated to him as Venn diagram. Remember one thing, be it maths or physics or chemistry or biology or any subject, there will always be two types of solution. One is analytical solution, one is graphical solution. There always exist two methods of solving. One is graphical and one is analytical. Graphical, which means you are drawing and then you are finding out the solution. It's not necessary if you want to solve linear equations. You have done your 10th standard and you have seen the chapter called as the linear equations, where you used to solve those two linear equations and used to find out the value of x and y. Now, if you plot a graph of both the lines, so where both the lines intersect, if from the graph you find out the coordinates of that point, it will be exactly same as the solution what you have got. So that is the graphical method. So for each and every type of numerical, there will always be some graphical method. Okay, remember that two solutions always will be there. So here also there will be two solutions. One will be analytical and one will be graphical. So let's see. So we saw in analytical there were two ways of writing. Okay, the set one was roster form, one was set builder form. Here also we are going to represent it by drawing a set. So suppose I have 15. So how I can represent this set A here? You draw any closed figure, any. Draw any closed figure, rectangle, triangle, pentagon, hexagon, trapezium, circle, rhombus, whatever you want to draw, you can draw. It's not compulsory that you should draw a circle only. The only thing is there is it should be a closed figure. Why closed figure? Because whenever we write a set, we open one bracket and we close the bracket. If you want to write a null set, you will write it as something like this only. That also you have to represent like this null set. You just have to write open curly bracket, close curly bracket. You don't have to write anything inside. Why? Because it is a null set. It is empty set. It is not having any element. Since it is not having any element, so therefore you are not going to write anything inside. This is how you represent an null set also. One open and one closed. So we are opening, then we are writing the element, and then we are closing. So when we are representing with the visual diagram, it should always be a closed figure. Any closed figure. It's not that only geometrical figure. You can also put something like this. Any random thing. But only the thing is it should be a closed figure. So I can do something like this and I can write 1, 2, 3, 4 and 5. So now when you write the elements, put a dot over there and then write an element. Put a dot over there and then write an element. Or you can write it something like this also. 1, 2, 3, 4, 5. You can write wherever in that empty space. In that empty space, wherever you want to write, you can write it over there. Or you can draw a figure something like this, a circle, and you can write 1, 2, 3, 4, 5. Okay, or you can draw a triangle, and then you can write these numbers 1, 2, 3, 4, 5. So this is the visual representation which we call it as Venn diagram. Now it may be looking very simplistic. Let's see. We are going to see the operations at that time. Also, I'm going to show analytical, and I'm also going to show you the Venn diagram of both. Okay. So let's see very important thing where the numericals are going to be on that only, which is operations of the set. Operations on set. Now set doesn't only consist of numbers. Set doesn't necessarily consist of numbers. If it is numbers, then the basic operations are for addition, subtraction, multiplication, and division. But when we're talking about sets, I said any well-defined object or thing. I can even make sets of vowels, I can make set of letters, I can make set of pens, I can make set of chalks, I can make set of pens, set of tube lights, anything. It need not be number always. I can make set of anything. So if I can make set of anything, then if I say okay, green chalk plus blue chalk, is it going to give me any result? Huh? It is not going to give me any result. Huh? If I'm saying 2 plus 3, then we know it is 5. But chalk plus pen is not going to be anything. Okay, banana plus mango is not going to give me anything. So you cannot do that basic operation which you have studied. So here the operations will be different, and these operations are logical operations. So the very first operation is union of sets, which will be denoted by U. Then the very next will be intersection of sets. It will be denoted by inverted U. Now union means or, intersection means and. Remember that. If I say A and B, it means A intersection B. If I say A or B, it means A union B. Then we'll see one more. after intersection, that is complement of a set, it will be denoted by A dash, whatever is the name of the set, you will write dash or you will write it as C. It means not set A, not set A. Complement means not. Then we'll see next operation. Difference of set. It can be shown by this symbol A minus B, or it can be shown by this symbol as A delta B. Okay, there are many different books use different notation. They put a minus sign and they put a circle over there. These are many different symbols which it use. It means only A. If I'm writing A minus B, it means only A. And if I write B minus A, then it means only B. Remember this English word, these are very important, which I am associating with maths. These English words are very important because when we are going to do word problems, in word problems we are going to use English. So we need to understand what is he basically asking. If we don't understand this, okay, associated English words will not be able to understand what is the given data and what is telling us to find. So let's try to understand. There is a set A having elements 1, 2, 3, 4, 5. There is universal set U having elements 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There is a set B having elements 1, 3, 5, 7, 9. There is a set C having elements 2, 4, 6, 8, and 10. Now let us try to find out. If I write A union B, so this means A union. Okay, this symbol means A union B. Don't get confused yourself with the universal set. Universal set is many times represented by letter X also. If you are getting confused, then let me represent it by letter X. Okay, so if I'm writing this, it means A union B. So what does it mean, A union B? You have to write elements of both the sets together. Okay, union means coming together, right? Not technically, English dictionary, technically union means coming together. Both the things are coming together. So when I write A union B, means both the sets you have to write together. So when I write both the sets together, okay, 1, 2, 3, 4, 5. Then set B. 1 and 3 I have already written. 5 also I have already written. So next 7 and 9. Why? Because we have seen in the beginning, one element can be written only once. So 1, 3 and 5 was already written. Therefore, I did not write this 1, 3 and 5 again. But 7 and 9 was not written, so I wrote 7 and 9. This is what I mean by A union B. Means write the elements of A also, write the elements of B also, and combine. If I write A intersection B, okay, this is the symbol. So this is what I've written. It means A intersection B. Okay. So A intersection B means you have to write the common things, common elements which are there in both. So there's 1, 3 and 5, and here also 1, 3 and 5. So these are common in both the elements. These are common elements in both. So your A intersection B will be nothing but 1, 3, and 5. Similarly, if I write A intersection C, then you can see over here which are the common elements. 2 and 4 is there here also, 2 and 4 is there here also. So your A intersection C will be nothing but 2 comma 4. If I write A union C, if I write A union C, then you have to write elements of A as well as elements of C. So elements of A are 1, 2, 3, 4, 5. And elements of C are 2 and 4 are already written. Then 6, 8, and 10. So this is A union C. 2 and 4 were already written, so one element can be written only once. So we cannot write 2 and 4 again. So I wrote 1, 2, 3, 4, 5, 6, 8, and 10. Okay, is that clear? Now let's draw the Venn diagram to understand how to draw the Venn diagram. So this is my set A, this is my set B, and if you see over here, I've done this overlapping. Why I have done this overlapping? Because we can see that in set A and set B, I have these common elements over here. These are my common elements. Okay, these are there in set A also, and these are there in set B also. So where and therefore I am doing this overlapping. So this much, if I cover this entire set A, so I said this is my set B. Similarly, if I cover this entire, then you will say that is set A. It means this portion of overlapping belongs to both the sets, set A also and set B also. So whatever common elements are there, I'll write them over here. So common elements in A and B are 1, 3, and 5. So those elements I'll write over here 1, 3, and 5. Then what are the elements which are not there, which are there in A and which are not there? That is 2 and 4. So I'll write over here 2. I'll write over here. Okay. Similarly, in set B, apart from 1, 3, and 5, set B is having 7 and 9. So I'll write over here 7. I'll write over here 9. Okay. Now if I cover this, you can say 1, 3, 5, 7, and 9. Yes, that is your set B. Now if I cover this, so you can say 1, 3, 5, 2, and 4. That is 1, 2, 3, 4, 5. That is your set A. So this is my right. This is my Venn diagram is right. So this is the Venn diagram of A and B. I've drawn something like this. Now let us see what is Venn diagram of A union B. If you see A union B, it is having 1, 2, 3, 4, 5, 6, 7, and 9. It is having these elements, it is having this element, and it is having this element also. Therefore, I'll shade this entire figure and I'll say that this is A union B because all these elements are there. Let's see what will be the Venn diagram of A intersection B. So set A, set B, 1, 3, and 5 are common. Then apart from there, this is 2 and here is 4 and here there is 7 and there is 9. So this is common. This common element is nothing but A intersection C. Yellow shaded portion indicates A intersection B. Here this entire shaded portion of yellow color was showing me A union B, and here this shaded portion which I have done with yellow is giving me okay a value of A intersection B. Similarly, suppose if I want to draw A intersection C, so I'll draw A, then I'll draw here C. I'll write the common elements, which are the common elements 2 and 4. Apart from 2 and 4, which all elements are there in A? 1, 3 and 5. Apart from 2 and 4, what other elements are there in C? 6, 8 and 10. So 6, 8 and 10. So A intersection C, again this shaded portion is A intersection C. So you take any set, any kind of set, always this overlapping region will always indicate A intersection of something. And the entire set together, both the sets together will always give you A union that particular set. So if you do A union C, you get 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 8 and 10, which means both the sets will come. So if I'm saying union, then entire yellow color will become union. So if I take B set and A set, or if I take A set and C set, or if I take B set and C set, to take any set, this figure will always remain constant. The overlapping will always indicate intersection. Both the sets together will always indicate union. Is that clear? Any doubts? Any doubts? Everyone has understood. This was analytical approach and this was graphical approach. Any doubts? No?
No, sir.
Okay, then let's move ahead and see next complement and difference of sets. First I'm showing you difference of sets. Okay. And then I'll show you complement. So if I'm writing A minus B, means this is A minus B means remove B from A. Means remove all the elements of B which are there in A. Which means remove common element between A and B. So if you see 1, 3 and 5 are there in A also and there are B also. So there's 1, 3 and 5 are elements of A also and they are the elements of B also. So when I say A minus B, which means you have to remove all the B elements from A. So when you remove all the B elements from A, so that is 1, 3 and 5. What remains is 2 and 4. So this A minus B is nothing but 2 comma 4. Okay, if I say B minus A, which means remove all the elements of A from B. So go inside B and remove all the elements which are common in A and B. So which are the common elements in A and B? 1, 3 and 5. So you have to remove 1, 3 and 5 from set B. So what remains is 7 and 9. So if you just remember what we have seen, this is only set A and this is only set B. If I write A minus C, remove all the common elements which is there between A and C. This 2 and 4, these are common in A and C. So when I write A minus C, so remove C from A. So you have to remove the common elements from A. So when you remove the common elements from A, that is 2 and 4. So what remains inside is 1, 3 and 5. If I write C minus A, which means go inside C and remove all the elements of A. So 2 and 4, these are common elements between A and C. You have to remove those elements and whatever elements are remaining that I write to those are 6, 8 and 10. So this is C minus A. Let's see the Venn diagram. This is set A, this is set B. Both are having common elements 1, 3 and 5. So that common elements are right over here. Apart from that, it is having 2, 4. Apart from them, there this is having 7, 9. So you see A minus B it is having only 2, 4. So this much portion. Okay, this indicates A minus B. And in this region, I have only two elements that is 7 and 9. So this much portion. Okay, this is called as B minus A. So it's simple. When you want to find out A minus B or you want to find out B minus A, what you're doing is you're removing the common element. So when I'm removing the common elements, I get only A. When I remove the common elements from B, I get only set B. So this is your only A and this is your only B. Okay. If I want to do of A minus C or C minus A, so let's see Venn diagram. So between A and C, you have 2 and 4 common. This is 2, this is 4. Then what remains in set A is 1, 3 and 5. What remains in set C is after that is 6, 8 and 10. If you see A minus C, it is 1, 3 and 5. So in this area I have written 1, 3 and 5. So this much region where I have written 1, 3 and 5 indicates A minus C. Similarly, if you find out C minus A, it is having 6, 8 and 10 which I have written in this region. So this much shaded portion. So this is going to indicate me C minus A. So this is the advantage of Venn diagram. It does not change. Okay. If it's intersection, only this portion will be shaded. If it's union, the entire will be shaded. If it's difference, you have to remove the intersection and whatever remains is shaded. So you bring any sets inside, the Venn diagram is not going to change at any cost. So now, since Venn diagram is not going to change, with any set it will always remain same. You can see over here. I have shown here for A minus B, B minus A. Here I have done for A minus C, C minus A. You can visually see and you can see that the Venn diagram for both is same. So if it is a difference operation, the Venn diagram will always be this. Let's see the last complement. Let's see complement of set. So whenever we say complement, okay, the complement is only find out if there is a universal set. So if I say complement of A, it is read as complement of A. It means remove all the elements of A from universal set. Remove all the elements of A from my universal set. Okay, for you I have indicated universal set with X. So if I am saying complement of A, it means remove all the elements of set A from the universal set. And then you write whatever the elements are remaining. So if I remove all the elements of set A, that is 1, 2, 3, 4, 5, what remains inside is 6, 7, 8, 9, and 10. So this is my A complement. Similarly, if I want to write B complement, means remove all the elements of B from universal set. So if I remove all the elements of B from universal set, that is 1, 3, 5, 7, 9. So what remains in universal set is 2, 4, 6, 8, and 10. If I remove all the sets elements of set B, that is 1, 3, 5, 7, and 9. So what will remain in the universal set is 2, 4, 6, 8, and 10. So whatever is remaining will be called as B complement. Similarly, if I want to find out C complement, so what I'm going to do, I'm going to remove all the elements of set C from where? From universal set. If I'm removing all the elements of set C, that is 2, 4, 6, 8, and 10, if I am removing from set, okay, universal set and then writing, then what will remain is 1, 3, 5, 7, and 9. So I've removed all the elements of set C from universal set. So what remains is C complement. So but of which what you have done is you have removed all the elements of set C and hence you will call it as not C. Hence you will call it as not B. Similarly you will say that it is not A. Okay. So is that complement clear? So let's see how to draw. Now whenever we bring universal set, this is fixed. This is fixed. For a universal set, you will always show one bigger figure and inside that you will draw a smaller figure. Why? Because all the elements of this set are there in the universal set. At the same time, universal set is having some extra elements also. Therefore, the entire set will always lie inside the universal set. Therefore, you will show universal set with a bigger figure and the next set with a smaller figure. So generally, the convention followed is you will show a rectangle and inside that whatever figure you have drawn, you can. So this I'll indicate here universal set I've indicated with X. So I'll write here X indicating that it is a universal set. Here I'll write A indicating that it is set A. Then I'll write all the elements which are there in set A, which is nothing but 1, 3, 1, 2, 3, 4, and 5. Apart from that, which more numbers are there in universal set is 6, 7, 8, 9, and 10. Right? This is my set A. So if I write A complement, so if you see the numbers which are there in A complement is 6, 7, 8, 9, and 10. So I'm going to shade this figure. So this shaded portion, the shaded portion indicates A complement. Similarly, suppose if I am drawing B complement, then I'll write X over here. I'll write B and all the elements in B. That is 1, 3, 5, 7, and 9. Apart from that, which other numbers are there? Over there is 2, 4, 6, 8, and 10. If you observe, in B complement we got those letters only. Those elements only 2, 4, 6, 8, and 10. So I'll shade that where I'm having 2, 6, 8, and 10. 2, 4, 6, 8, and 10. I'm going to shade this. This is going to be my B complement. Similarly, if I want to draw a Venn diagram of C complement, again I will take a universal set. I'll draw the set C. I'll write the elements in C, which are 2, 4, 6, 8, and 10. And all the remaining elements which are not there, I'll write over here. Those are 1, then 3, then 5, then 7, then 9. Okay, these numbers are not there. Those are written over here. So if you see the complements also have that letters only 1, 3, 5, 7, and 9. So I'll shade that portion where I'm having 1, 3, 5, 7, and 9. So this shaded portion is nothing but my C comp. Matter if you write A, B, C, D, whatever you said, right? It doesn't matter. The Venn diagram for the operation will always remain the same. You can see one is shaded with yellow color, one with pink color, and one with blue color. You can observe that the same region is shaded in all the cases. And therefore it doesn't matter whichever set it is, the Venn diagram for a particular operation will remain same. Okay, so we have seen this four operations. Hope you have understood all the four operations. Hope you have understood all the four operations. Okay, please take the screenshot also. Time to time, have a habit of taking the screenshots also because okay, due to very less amount of time which we are getting for the lecture, I cannot give you time for copying it down. You have to take the screenshot or you have to go through the videos and then you will have to make the notes. And if possible, I'll give you the notes also as a soft copy. So today we have completed what is a set, types of set, okay, methods of writing the set, and now we have seen, okay, operations of the set, and we have seen their respective Venn diagrams also. I hope everyone has understood. If you have not understood any operation, then please let me know. These are the four basic operations which we do on a set. Okay, complement, union, intersection, and difference of a set. Is that clear? Whatever we have done today?
Yes, sir.
Clear?
Yes, sir.
So move ahead. If it's clear to you guys, let's move ahead
Yes, sir.
and see one more topic, which is called as Cartesian product of a set. This is indicated by this symbol. So a product of two sets. Okay, product of two sets. So when I'm saying product of two sets, you are not going to multiply because you can multiply the numbers, but you cannot multiply the things. Pen into chalk is not going to give you anything. Okay, Chiku into mango is not going to give you anything. So when I'm saying Cartesian product, so what is the product of two sets? It means nothing but ordered pair of elements. Understand this word very properly. Ordered pair. What does the order mean? One after another. If I'm saying 1, 2, 3, 4, 5, it means okay, 2 comes after 1, 3 comes after 2, 4 comes after 3. This is the order. And this will always be the order. So this is what I mean by order. So if I'm saying that you have to follow this order,
Hello, hello, bro.